Let's now discuss the equality property. If both sides of an equation consist of a single logarithmic term with the same base b, then the arguments are equal to each other. So this is saying that if we have an equation that has a log on both sides and both logs have the same base, then that must mean that the arguments are equal to each other as well. So a log of base b of x is equal to the log of base b of y would mean that since the log and the bases are the same, x must be equal to y. And we are still adhering to the rules that we set earlier in the chapter. B, x, and y must be positive, and the base is not equal to 1. So let's say we were given a log of base 3 of x is equal to the log of base 3 of 10. Since we have a log on both sides with the same base, we can set x, the argument on the left side, equal to 10, the argument on the right side, and thus x is equal to 10. Let's say we were given a log of base 2 of 3x is equal to a log of base 2 of 24. Since we have a log of base 2 on both sides, we can set 3x equal to 24, and then we can solve for x from here. So this is how we want to use the equality rule to help us solve for x in an equation that has logs on both sides. But let's walk through another example from the beginning. Let's say you were asked to solve for x and check the answer for a log of base 5 of 12 plus the log of base 5 of x is equal to the log of base 5 of 36. So how would we solve for x in this equation? So since we are adding logarithms that have the same base here, we can use the product rule to combine these two terms. So step 1, combine the logarithms on the left side by multiplying the arguments 12 times x. So that would give us a log of base 5 of 12x. And that's equal to a log of base 5 of 36. And now that we have a log on both sides, and they each have the same base, we can now set the arguments equal to each other. So that would give us 12x is equal to 36. And now we can solve for x. So we divide both sides by 12, showing us that x is equal to 36 divided by 12, which means x is equal to 3. And now, step 4, we can check the answer by plugging it into the original equation. So when we plug in 3 for x, we get the log of base 5 of 12 plus the log of base 5 of 3. And since we're adding logarithms, we can use the product property to multiply 12 times 3, which allows us to combine them to a singular log, giving us the log of base 5 of 12 times 3, which is 36, showing us that we get a log of base 5 of 36 is equal to a log of base 5 of 36, confirming that x does equal 3. And that is how we go about solving logarithmic equations that have a log on each side. Let's now have you try a few practice questions. Solve for x and check the answer. Question number 1. The log of base 2 of 4x plus the log of base 2 of 6 is equal to the log of base 2 of 72. Question number 2. The log of base 3 of 2x minus 2 times the log of base 3 of 6 is equal to 0. In question number 3, the natural log of 8 minus the natural log of 2 plus x is equal to the natural log of x. Pause the video, answer these questions, and then press play when you are ready to begin. question number 1. We have the log of base 2 of 4x plus the log of base 2 of 6 is equal to the log of base 2 of 72. Step 1, combine the logarithms on the left side by multiplying the arguments 4x and 6. 4x times 6 would be 24x. So now we have one log on each side of the equation, and they have the same base, which means we can set this argument, 24x, equal to the argument on the right side, which is 72, which would then allow us to solve for x. And we can do so by dividing both sides by 24, showing us that x is equal to 72 divided by 24, which would be 3. And we can check the answer by plugging it into the original equation here for x. When we do so, we get the log of base 2 of 4 times 3, which is 12. And the log of base 2 of 12 plus the log of base 2 of 6 means we can multiply 12 times 6 using the product rule here. And 12 times 6 would be 72. So we find the log of base 2 of 72 is equal to the log of base 2 of 72, confirming that x does equal 3. That is the answer to question number 1. Let's now have a look at question number 2. We were given the log of base 3 of 2x minus 2 times the log of base 3 of 6 is equal to 0. Step 1, we want to move the second log to the right side. So we add 2 times the log of base 3 of 6 to both sides. So this now allows us to have one log on each side, and they both have a base of 3. We want to move this coefficient 2 to the exponent of the argument 6 here, which would make the argument 6 squared. And now, since we have a log of base 3 on the left side and a log of base 3 on the right side, we can set the arguments 2x and 6 squared equal to each other. And now we can solve for x. 6 squared is equal to 36. And now when we divide both sides by 2, we find that x is equal to 36 divided by 2, which is 18. So the answer to question number 2 is x is equal to 18. And we can check the answer by plugging 18 into the original equation for x here. So for this argument, we get 2 times 18, which is 36. And this term here, the argument is equivalent to 6 squared if we move the 2 to the exponent, which means this argument is 36. So we get a log of base 3 of 36 minus a log of base 3 of 36, which would be 0, giving us 0 is equal to 0, confirming that x does equal 18. That is the answer to question number 2. Let's now have a look at question number 3. We're given the natural log of 8 minus the natural log of 2 plus x is equal to the natural log of x. Step 1, combine the logarithms on the left side by dividing the first argument, 8, by the second argument, 2 plus x. Since this is subtraction, we are using the quotient rule to do this. So this now gives us one log on the left side and one log on the right side, which means we can now set the arguments equal to each other. So we set 8 divided by 2 plus x is equal to x. And now we want to multiply both sides by 2 plus x to cancel out this denominator, leaving us with 8 is equal to x times 2 plus x. If we distribute this x to each term inside of the parentheses, that would give us 2x and x squared. So we wind up with x squared plus 2x is equal to 8. We'll now subtract 8 from both sides, giving us x squared plus 2x minus 8 is equal to 0. And we will now factor this polynomial to solve for x. So we want to find two factors of negative 8 that have a sum of positive 2, and that would be positive 4 and negative 2. So we can now set each of these factors equal to 0 to solve for x. So x plus 4, we set that equal to 0. And to solve for x, we subtract 4 from both sides. So one possible value for x is negative 4. And to find our second potential value, we set our second factor, x minus 2 equal to 0. And now we solve for x by adding 2 to both sides, showing us that x is equal to 0 plus 2, which is 2. So we have two possible values for x that we want to confirm, negative 4 and positive 2. So we plug the answers into the original equation. So we'll start by plugging in negative 4 in for x here and here, giving us the natural log of 8 minus the natural log of 2 minus 4, which would be negative 2. And we cannot take a log with an argument that is negative. This is undefined. And so is this term, the natural log of negative 4. So we find that x is equal to negative 4 is not a value for x. And now we test positive 2. So we plug in 2 for x here and here, giving us a natural log of 8 minus a natural log of 4 is equal to a natural log of 2. And since we have subtraction here, we'll use the quotient rule to combine these terms. So it'll be the natural log of 8 divided by 4. And 8 divided by 4 is 2. So we find that the natural log of 2 is equal to the natural log of 2, confirming that x does equal 2.